Right, so this video is about cracking. I'll just make separate videos for each of the reactions that are relevant so you can work through them at your own pace. Okay, so if you looked at the introduction, you'll see that this is the first one and it applies to alkanes only. So we're going to really focus on what it's useful for and how it works, right? What is actually happening. It's actually not that far. It's actually a straightforward enough reaction. Okay, so if you read in the notes here that not all fractions that are obtained by fractional distillation are in high demand, shorter chain, lighter molecules are in higher demand. So that means that like the fewer carbons, right? So crude oil is a mixture. There's no control over how the mixture is, whether it has larger or smaller molecules. So it just happens that the smaller molecules, like those with 8 carbons, octane, right, for example, are more useful as fuels than, say, those with 20 carbons, because they kind of get very viscous and gloopy as, the molecules get larger, then the actual liquid gets very, hard. It's difficult to make it flow and so on. Okay, and it doesn't burn as cleanly. Okay, so if you, after fractional distillation, you have a process, you can do a process called cracking to get more of the molecules that you want. Now, so fractional distillation, remember, will give you certain fractions, right? Okay, so you've separated out your crude oil into distillation, right? So your crude oil has gone in to a fractionating column and you have got fractions from that. And you have a range of fractions from refinery gases as the lightest, right? So that contains the smallest molecules, and then very bottom is bitumen, right? Which would have the largest molecules with the highest boiling points. Okay, and in between you have your petrol, diesel, and so on, right? Now, what you're really interested in is, you want as much of the, whatever is commercially viable, right? Whatever sells, that's what you want. So some of the fractions, and remember, we're talking about alkanes here. They're alkane mixtures, right? So say you have, now I'm just mentioning that, say, Venezuelan oil, right? Crude oil tends to have a lot of the larger molecules in it, whereas the stuff you get in Saudi Arabia tends to have more of the smaller molecules, right? So say you have a sample of a fraction from Venezuela, and an awful lot of it has got 20 carbons in it, okay? And remember that for an alkane, the general formula is CnH2n plus 2. Okay, so say you have, so that would have 42. So say you have got an awful lot of C20H42. I'm not even going to try and name it. Okay, so what you can do is you can it can undergo a chemical process called cracking. Right, and what cracking gives you is it basically breaks down your large carbon chain into smaller carbon chains. Now, what you'll get is your large alkane, right, will be broken down into alkenes, either one or more, right? Let's see why. It could be one or more, and one shorter chain alkane. Now, you'll only get one alkane from this. And we'll see why. Shorter chain alkane. Okay. And you basically break the molecule. If you consider it cracking, right? So if you consider your carbon 20, it's 20 carbons long, and you just snap it chemically into smaller bits, right? Now you can do that. This cracking process, you can use heat or a catalyst. So you have either thermal cracking, right, where you just heat it up in the absence of air, because if you've air there, it'll just burn, right? So thermal cracking is heating it up, and that'll make it break apart. It'll decompose, okay? It's a thermal decomposition. And catalytic cracking will happen at a lower temperature in the presence of a catalyst. And remember, catalyst, if you remember from the rates of reaction, catalyst speeds up the rate of reaction, right? And it does this by providing a an alternative pathway of lower activation energy, right? And the catalyst doesn't get used up itself. All right, so let's have a look at the notes again. Oops, that's not the notes, that's your learning log. Right, so what we have here is an example of, so you can have a read of that yourselves. Okay, so really we've mentioned everything that's in the notes there. Now we've got an example here of heptane giving you ethene and pentane. So remember that you've got, a heptane has got, you don't need to know this, they would have to give you the name and chemical formula, right? If they being nobody at this stage, me. Okay, so heptane has got 7 carbons. I'll just make that a little bigger if I can. I'm going. Okay, heptane has 7 carbons, so it has 2 N plus 1 hydrogens. So C7H16 is its molecular formula, right? And it can break. Now, there's a number of ways that you can crack it. So basically, I want you to think about it like this. You can break any of those carbon-carbon bonds, all right? So you can get a range of different products. So any equation you write will only show one possible outcome. Okay, so you have got, say, C7H16 can give you, if we break the bond, now I'm going to have to steal this into the, right. Let's pop that in there so we can mess around with it. Okay, so that's from the notes. So what you have is, we're going to get C2, so ethene, okay, so remember that ethene is that, C2H4, that is one you need to know. Pentane you don't need to know. Pent means it has 5 carbons. Hept means it has 7. Now, there's a few things I want you to note here. The first thing is that there's the same number of carbons and the same number of hydrogens on both sides, right? And just remember that your general formula of an alkene is CnH2n, and for an alkane it's CnH2n plus 2, okay? Just that's worth mentioning here. Now your C7, so here is your heptane as the structural formula. So 1, 2, 3, 4, 5, 6, 7 carbons. It's giving you ethene and pentane. Right, not one you need to be able to draw, but hopefully you'll see, you know, that you just stick in, you know, as the molecule gets larger, just adding a CH2 every time. Okay, so in this instance, we've broken the bonds here. So the cracking, right, bit has happened, it's broken that. And effectively what's happened is this hydrogen, right, or well, one of the hydrogens, has gone on to this carbon, no, sorry, it's gone on to this carbon here, right? So then you're left with, and you end up with a double bond here, because remember, all carbons have to have 4 bonds around them. So if you can picture that, right, you've broken the bond between the 2nd and 3rd carbon. It's now, so that everything ends up with its 4 bonds around every carbon, that hydrogen then ends up on this carbon, and these electrons, so that's what they are, they'll end up as part of this carbon-carbon double bond, all right? Now you'd have an alternative here, right? You don't have to break, it doesn't, it's, you know, it's random really where it breaks. In reality, if you were to do a cracking process, you'd probably get a mixture of different products. So supposing we changed where that was broken, and I'm going to do it I'm going to just change that on the next slide and look at an alternative. I think I can just, so I've put it in again, okay, just so I can show you, draw an alternative. Okay, so what we could do is we could actually break it at, let's just see, yeah, if we break it here, we get a different set of molecules. Okay, so you could also have this. Now, if you broke it there, well, there's a couple of alternatives. Now, the only thing to remember is that one of your products has to be an alkane and one of them has to be an alkene. Okay, it doesn't matter which. So let's take this. This has 4 carbons. Let's make that our alkane. Okay, so this hydrogen is going to end up onto that carbon, and we're going to end up with 4 carbons and then hydrogens, and you should, this is one of the ones you need to know, you should be able to name it. Congratulations, it is butane. Now you can pause this video at any point to have a go with this yourself, right? So that's butane. And then what are we left with? This other one has 3 carbons. Now, because we don't have an alkene yet, so one of these is a carbon-carbon double bond, and then we have hydrogens, making sure we don't overdo it. So only 1 hydrogen on that central carbon and 2 on the end carbon. It doesn't matter if you put them, what angle you put them at, you can put them top and bottom, as long as you have the correct number attached to the correct atom. And this is a bit scruffy looking here. Okay, so, and that is called propene. Now, to be honest with you, you could have also had butene, but1 or but2ene, and propane, right? So you have a number of ways that this can break. Okay, so depending on where you break the bond, then you will just have different products produced. Okay, so you can probably think of another one you could have, right? So have a think about that. I'll just put other combinations you could have are butene, either but1ene or but2ene, and propane, right? You could have ethane and propene. We're not worried, there are different propenes, but we're not going to worry about those. You could have that. You could have, if you just broke the bond between the first and second carbon, you could have methane and hexene, or right, you can't have methane, obviously. Okay, so there are a number of ways that this can work. There can be a number of products formed. Right, so back to the notes. Now, definition of cracking. It's the breakdown of larger saturated, remember, hydrocarbons into smaller, more useful ones, some of which are saturated. Oh, that shouldn't be that. Hopefully you should have spotted Dr. Carey's mistake. That should say unsaturated. And I can't change it there. I must change it in my own notes. Right, so just make sure that you change that to unsaturated, because unsaturated is when you have it. So if you spot any other mistakes in my notes, please let me know. I'm just going to actually change this mistake now so that when I'm teaching this again, it doesn't come back to bite me. Hopefully. Okay, so that should have been. Sorry about this, gentlemen. Just fast forward until I. Oh my goodness. Right. So there we are. They're unsaturated. Okay. Go back to your notes. Right. You can get more than 1 alkene, but you can't get more than 1 alkane. Right? You could get more than 1 alkene. So let's have a look at that. Now, this is from the revision book, this next bit. Okay, so he's talking about octane being cracked to form butane and ethene. So let's have a look at this one, all right? And I'm going to lift that. Work it through in the video. As I say, at any stage, you should pause and have a go with this yourself, right? And just start the video again to check your answer. I'm just going to obviously talk on, but I'd suggest you do that because you really need to be practicing, not obviously just listening to me or pretending to listen to me or whatever. You should be doing some work and doing what I'm about to do before I do it, if possible. Okay, so what you got here is octane. So we're going to write the chemical formula of octane. Okay, and they've told us it's cracked, so we're going to break the molecule into butane and ethene. So for some reason, they've given us the chemical formula of ethene, even though that's one you need to know. Right, so we know that we're going to definitely form ethene and butane, which is C4H10. Now, we have a bit of a balancing issue here, though, because in order for this, right, whatever you're going to have, obviously nothing be created or destroyed. Now, I have 8 carbons here, and we've 2 plus 4, so we've only 6 carbons over on this side. Now, you would add more. You can only have one alkane, but you can have more alkenes, right? So if you're going to balance it, make sure, so in order, we need 2 more carbons. So we're going to double this. And now let's see whether that adds up. So you've got 8, right, so our carbons are grand. What about the hydrogens? 8 and 10 is 18. Now, if you should check and try and balance it with, say, ethane or something. You'll find that you don't have enough hydrogens in your beginning alkane to make that happen. Right, so you can draw out, if we were to draw the actual molecules and show where it's breaking, so see, and so you can fast forward to the end of this, and take me a bit of time to draw it. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and our hydrogens. I apologize for any dodgy lines. Okay, so there is actually, any of you who are brave enough to do A-level chemistry, there's a shorthand version of drawing this with like zigzag lines. So it's not like you have to draw all the molecules like this forever. Everybody's fundamentally trying to find the easiest way to do everything. Okay, so we know we're going to get C double bond C. And C, 1, 2, 3, 4. Okay, now if you have a look, you'll see that the bond breaking, right, the cracking bit, whereas it's cracked, it's between the second and third. So the bond is breaking there, but actually it's also breaking, well, let's put it here, doesn't really matter. So here as well, right? And the hydrogen then, this hydrogen is transferring onto here. And so we've got 2 of these. 2 of those form. Now, yes, you should be asking yourself, could it go again? Yes, absolutely. You could also break it here. You will definitely have 1 alkane. Remember that? So you could have 3 ethenes and ethane. Okay? So that's the way it works. Okay, folks, so what your job is now is to have a go at questions 45 to, oh wow, I have tons of them, to 73. All right, so that is the job, and I will be posting that Jamboard thing at the end, and it'll have all the answers in it.